Hello, everyone. Thank you all for joining today. We have a very exciting agenda for you all today. We have a topic called Navigating the Depths of API Security Testing. My name is Horace. I'm one of the product managers working on Microsoft Defender for Cloud. I'm joined by my colleague Preetham here, who's also a product manager on Defender for Cloud. We also have representation from the 42Crunch team as well. They have a tool that specializes in API security testing, so we'll be walking through a demo of that, along with how to integrate that within your existing developer workflow. So we're joined by Heshaam for that demo. And then we also have Sunil here as well that will help moderate the online chat, along with answer any questions that you drop in there as well. So with that, we can get started with the agenda. So for today's topic, we have a couple of items that we'll be covering. The first one is really just to detail why is API security even important and why you should even care about it when it comes to developing new API applications. The second topic, we'll be walking through real-world API breach examples. So we'll go in depth to see exactly what went wrong with those specific cases and see how easy it is to actually introduce API security vulnerabilities within code. We'll also take a deeper look at broken authorization, one of the top risks when it comes to API security. And then we'll go through a demo walking through how to actually automate security testing for APIs within your existing developer workflows as well. So including both your IDE environments along with any DevOps pipelines as well. And then once we have time at the end, we can use that for Q&A along with wrapping up with some references for learning more as well. So just to make this a little bit more interactive as well, we do have a Menti poll here, so please feel free to join if you would like to from your phone. We have just menti.com, and then you can go to that, type in that code there. Completely optional if you would like to join. And essentially what this will do is we'll have just different questions sprinkled in throughout the presentation just around API security, and along with understanding a little bit more about your role and where you are with your kind of API security journey within your organizations as well. So I'll give a little bit longer for anyone that would like to join that. Again, completely optional, and all responses are completely anonymous as well. And then the first question that we have is just a fun one to see where in the world everyone is joining us from as well. So seems primarily from West Coast in North America, but we have some folks from Europe as well. Thank you all for coming. Great. It seems like pretty much from all across the world, primarily from North America, though. So yeah, that's great to see there. And then the second question that we have is just to understand, if I go here. The second one is really just to understand what matches your role closely. So this is a developer conference, so I think majority might be on the developer side, but of course, these roles can really vary as well. So we have IT admin, SecOps, security consultant, cloud architect, and then if that's not covered as well, feel free to put other as well. Great. It seems like a little bit of each role here, so that's great to see as well, primarily on the software engineer developer side. So great. And then with that, we can go back to the presentation then. And then the first kind of topic that we'll walk through, as we mentioned, is really why is API security important? And just to give you some kind of background information on this, the first one is really just knowing that APIs are ubiquitous nowadays. So whether you're booking travel online, whether you're looking up weather in your search engine, chances are APIs are what's powering those various digital experiences. According to some reports, 83% of web traffic nowadays is actually API-based traffic. And then the second key metric here is that traditional API security measures are inadequate. So your organization may already be using some tooling for API security. That might include a web application firewall or an API gateway system. And those tools are great and do provide some level of coverage when it comes to API security. But to have a comprehensive API security solution, you'll need to supplement that with existing tools as well, some that will be part of your developer pipeline with dynamic testing of APIs, along with runtime security solutions specific for API related risks as well. And then the last piece that we have here is that APIs are really one of the top attack vectors today as well, and many of the recent kind of attacks that we've come across are related to API compromises. And just to expand on that just a bit here you're seeing just a small subset of the number of API-related attacks that we've come across over the course of the past couple of years. What I will mention is, especially within the past year, this number has really skyrocketed as well. And you can clearly see the impact that these API-related compromises are having for organizations. So you're seeing here millions of dollars worth of fines, for example, sensitive data being breached as well. And sensitive data is a really important topic when it comes to APIs, as APIs typically and by nature do expose some sort of sensitive or PII data. So oftentimes when an API is compromised, it does result in some sort of sensitive data breach as well. But that's just one example of an API compromise. A compromised API can also lead to full service disruption, so taking down a service, for example, along with full account takeover access as well. And then just to kind of wrap up the why API security is important, here is kind of an analogy that represents the current lay of the land when it comes to APIs. So this is the more previous architectures, typically with more monolithic style of applications, where you had kind of one or very few servers within your organization that were exposing all these API endpoints or web endpoints in that case. And you can see a more fortress style of security in this case, where you can have specific firewalls in place, for example, and you have a good understanding of what all data is going in and what all data is going out of your applications. So this is a world with more monolithic style application architectures. But as we move to more microservice-based architectures, now we have this world where, hey, people can have direct access to your microservices. So now you've broken down the monolithic service into multiple kind of chunks in this case. And these microservices will communicate with other microservices. Some might be internal, some might be externally exposed. And it really expedites this problem for security teams to really understand, hey, where is the data going? What type of data is flowing? Do I handle authentication correctly? Do I handle authorization correctly? And that's really where the problem of API security starts. And then just to expand on that as well, I do want to introduce the OWASP API Security Top 10 as well. So OWASP is a nonprofit security research group that really focuses on various aspects of cybersecurity worldwide. They're very famous for their OWASP Web Top 10 list. This is actually a different list. They have a specific list focused on API security risks as well, and this basically enumerates what they see as the top related risks when it comes to APIs today. So if you are interested after this talk to learn a little bit more about API security risks, I would highly encourage you to take a look at this link here. And you can go through each of the different items that they have enumerated there. They walk through specifically on how easy it is to introduce any of these vulnerabilities within code as well. So with that, let's get started by actually deep diving into a few real-world API breach examples. And the first one I want to walk through happened to a global shipping company in this case. And what happened is that security researchers were able to discover that they could call a series of APIs to basically retrieve personal PII data for the customer base of that global shipping company. The first step for this was to call an unauthenticated public API endpoint. And in that API endpoint, they had to pass a parcel ID number. This parcel ID number is a numerical number, around 10 digits or so, easily guessable in this case. And what would happen is if you input that parcel ID number, in response, you would get some metadata about the shipping item in this case, which would include a map of the location of the destination. So a link to the map, just like you're seeing here. And then what researchers were able to uncover in this case is they could look at that map and see the street names, for example, and basically derive the postal code from that map itself. So now they have both the parcel ID number and the postal code. And then there's a second API endpoint, also unauthenticated in this case, where if you input both the parcel ID number and the postal code, it would return back full details about that shipment. So it would return back contact information about who made that shipment, including their email address, their phone number, their name. If the package was delivered, it would show the person that delivered it along with their picture as well. So this could clearly have a big impact if it were to be exploited as well. So in this case, you can see, for example, this global shipping company, they actually handle over 2 billion parcels every year. So if this were exploited, you could see how big of an issue this could have been, where you could basically exploit the entire user base in this case. And some of the causes for this. The first one is what we call excessive data exposure. Essentially what this is you have an API that's returning more information than it needs to. And this is often the case. Sometimes what happens is you might have an API where the response returns back a lot of information, and it's up to the client to basically filter some of that information out. And it's not a best practice, as you can see, for example, security researchers might be able to access the non-used data, for example, and use it for certain cases as well. So this is really case by case. It depends on your specific business logic, but the best practice is really to minimize the amount of data that you're sending back and make sure that you don't lead to a path that can accidentally be exploited in this case. We also call this here broken user authentication in this case, more so the lack of authentication in general. Typically when you're dealing with sensitive data such as contact information or personal information, you should have a stronger form of authentication in place. In this case, the only authorization was based off of that both the parcel ID number and the postal code in this case, which was not enough. So in this case, that was able to be exploited by the security researchers. And then the last one that really expedites the breadth of this impact is called lack of rate limiting. So in this case, researchers were able to basically enumerate and call this API endpoint hundreds or thousands of times without any blockage. There was no blocking their IP address or stopping the API attack from going on, which basically makes it so, hey, researchers were able to go and kind of enumerate through an entire user base if they would like to as well. So there was example one. The second example is really for a smart scale application. So the way that this works is you download a mobile application that links to your smart scale, your physical kind of a scale that you have, for example, in your house. And the way that this works is users can create accounts, they can add family members. It's mainly just for tracking health data. So there were two vulnerabilities that happened with this particular case. We'll walk through both of them. The first one, just to give some background information, is you first have to register for an account. And when you register for an account with this application, it returns you a 9-digit user ID number. So that's basically what you're seeing in that picture here. You're seeing the register API endpoint, and in the response, you're seeing a user ID coming back in this case as well. And in this case, the researchers found that the user ID actually has a common pattern. So the first 4 digits of that user ID seem to be repeating when they tried to create new users or adding new family members, for example. So what they did was, for the last 5 digits, that's something really easy to brute force and kind of enumerate through. And that's exactly what they did. So what you're seeing in that screenshot there is basically enumerating through all of the last 5 digits for all the user IDs. And they're able to get sensitive data for other users within that are using that app as well. And that sensitive data included their first names, their birth dates, along with their profile pictures as well. What's really interesting about this case is that this is an authenticated API endpoint. If you can see within that requester, one of the headers is the access token in this case. And essentially, that means that, hey, this is an authenticated API endpoint. However, the authorization was misconfigured. So you, as an authenticated user, were able to access somebody else's data. And this is one of the most common exploits when it comes to APIs, as well as it requires the development teams to basically have authorization checks at every stage within their application. So in this case, we call this broken authorization. And we'll deep dive into this a little bit more later in the presentation as well. The second vulnerability that happened with this particular application is that the reset password API endpoint would send a 6-digit code to an email address. So you would fill out a form and say, hey, I forgot my password, and it would give you an email address that includes that 6-digit code in this case. The vulnerability here, though, is that 6-digit code is an all-numerical value that's easily guessable or easy to brute force in this case, and that API endpoint that verifies that doesn't have any rate limiting in place. So researchers were basically able to just brute force that API endpoint and call every single possible 6-digit code until they were able to successfully change the password in this case. And once they change the password, now they're able to perform a full account takeover in this case. So that includes doing any admin functionality, including adding and removing users, along with accessing full sensitive health data as well for all the users. So similarly, in this case, the potential impact could have been extended to over 500,000 of the users of the apps in this case, but these vulnerabilities were disclosed by the security research team, and they were remediated 7 months after the disclosure. And that is a really important piece here because it is really difficult to actually retrofit and go back and fix some of these vulnerabilities once they've been deployed as well. So it does take time for that piece here as well. And the main difference here in the cause is that this also includes broken object level authorization. So again, in this case, that basically what happen is you have an authenticated API where the authorization was misconfigured in this case. For the lessons learned, the only kind of key difference here is that when you're dealing with user IDs, you should use something more like a GUID or UUID, a longer string in this case that's random, instead of relying on something that's an easily guessable pattern. And then the last one is you should return the minimum information needed, especially when you're dealing with sensitive data in this case as well, when it comes to dealing with API endpoints. So next, we'll go to the third example, and for this, I'll pass it on to Preetham to help cover this one.
Thank you, Hes. Just like we saw in the previous two cases, API risks can they're literally not limited to a single industry or a specific type of technology, right? They span across industries. We saw a global shipping company, retail. We saw, smart scale IoT devices which are exposing APIs. But the next one we'll see is another very popular example, which was a cryptocurrency trading platform. And in this specific case, you can see that it was very interesting. Now, there was white hat researchers or hackers who kind of discovered a critical flaw in a very popular trading platform where they were able to sell and trade the assets, in this case, their cryptos, even though they did not have that in their crypto wallet. How did they do that? One of the researchers tried to, he owned a bunch of Ethereums in this trading platform. And he was trying to see what are all the information that I can get when I use an API of this crypto trading platform here. On the right-hand side, you can see that he's tried to enumerate a bunch of different asset IDs for his Ethereum account. And then when he tried to access a different kind of an asset that he did not even own, to his surprise, he was able to successfully get at accessing that particular asset. He did try to reach out the owners or the company itself. Nobody responded immediately, so the researcher went ahead and even tweeted about this in Twitter, and it's public. You can see it. So what did he do in this case? Let's see. The first, he basically had the option to sell his Ethereum assets that was part of his wallet, and he tried to ping this API which contained the Ethereum. And then he saw that in the response that he was receiving, there was no proper validation checks. When he was able to initially authenticate, the trading platform did have the authentication that he had to pass. But then when he wanted to trade that, which means now I know that I have Ethereum in my account, now I want to go ahead and sell those. But instead of selling Ethereum, he switched the asset to Bitcoin. And to his surprise, the transactions went successfully without giving him any kind of failures. This is a very classic case of how even initially when the users actually can authenticate their existing assets to sell and kind of perform any kind of operation. But the critical flaw in one of the parameters, in this case it was the product parameter itself, allowed him to manipulate whatever authorization he has on that assets to sell a different kind of a product in this case. So mainly what is the key impact? It was responsibly disclosed, so he did report it to the organization. The impact was minimal in this case, but it could have put millions of users who are using the platform at risk, even brand reputation damage to the entire company. The other thing we noticed is that the trade itself was disabled for 5 hours. What this meant was the researchers or the engineers from the company responded to the researcher, and they actually stopped any kind of trading for the rest of the day, and until they fixed this issue, right? This is a classic case of BOLA exploit, or a broken object level authorization exploit. And the most important thing is there was a bug bounty. He was awarded about $250,000 for finding this flaw, reporting it to the company. The main lessons, what we see from this is that ensuring that you always validate the access or to objects of all the requests, every APIs that are exchanging and transacting with the end users. Second is implementing additional checks. Yes, we need some initial checks to make sure that I have access to a specific API or a code within the API, but then at every single stage of these API checks, do I have proper validation? Are there any misconfiguration which could have avoided such a significant or an important miss, right? So with this, let's look at another example here. Let's take a closer look at this, right? I'm probably going to pose a question to the audience here. Let's say this is an online store app, right? So, and you have a code here. Maybe take a look at it for 10 seconds and let me know if you can spot any issues that you find here. If there is a flaw in this code, and where do you think the flaw is? Mm-hmm. Yes, you're very close. Incremental value, yes. But then there is also one more which directly hits the authorization here. So let's take a look at it, right? So if you actually look at the validation here, this popular app store will define what the order ID is. It basically gives you a UID, which is a straight string numeric digit that is defined on the top. And as you go down, you can see that when the current user is checked against the order, it first checks if the user is owner of that particular order. But then when he's going down to edit or change that particular order, there is no authorization, or there is no check or a validation that is performed when the orders are being edited as well, right? So this is telling like, okay, I can have some initial checks that can be performed, but then along that supply chain of the whole order management in this case, within this app, these kind of misses or misconfigurations can lead to the hackers creating the orders, editing the order, creating the orders, or supplying the orders to the order management. But then when they want to change the order, they can put any other different order IDs and then still get through the system because there are no proper checks that are performed along the way. The example is a good way for us to reflect that APIs are programmatically accessed. When we see vulnerabilities or misconfigurations in the APIs, they're code vulnerabilities, which means these also have access to threat actors or anybody who's trying to misuse the use of an API itself. And they can be programmatically hacked, and it can scale such attacks, right, with such authorization flaws. Let's kind of look at this in a more real-time demo, which my friend Heshaam will be presenting us, going over how can we look at some of these flaws in the code itself and where and how we can test for some of these issues and present to you what is the solution for it. Thank you.
Hey, everybody. I'm Heshaam Attar from 42Crunch. We're a proud partner of Microsoft since late last year, November. And we focus on automating security testing for APIs, but also really ensuring no unsecure APIs can reach production through that automated testing. So before we get into it, I'll just ask a couple questions for the audience here. So back to the Mentee. Does your organization require security scanning of any kind in your DevOps pipeline today? So your pipelines where you're automating pushing code, continuous integration delivery, do you do any sort of security scanning, SAS, DAST, SCA? Those are just acronyms for static and dynamic analysis of code. Seems about 50-50. So, and yeah, it's actually pretty common today, right? Like you have many SCA solutions, software composition analysis, or static analysis, dynamic analysis tools that will analyze the actual source code, whether it's an API or web app or what have you, right? Next question here. Does your organization already have tooling in place that tests specifically for API security vulnerabilities in the code? Yeah, we're kind of spread out on this one. This is expected, right? APIs are generally newer, right? In the past 10 years, they've really evolved and exploded in terms of deployments, right? So this is something that's becoming more and more mandated. APIs bring their own set of challenges, and so really what we're starting to see is you need your own specific tool set for those APIs in order to automate that testing. So flip over here. So what's really the issue, right? Development, they play hard to catch. What does that mean? Well, developers today, right, they move quick, they're very talented, right? And they're in big numbers, right? There's tons of developers. When you compare to AppSec, your application security teams, they really are sort of outnumbered today. So it's hard to keep pace with those fast-paced deployments, growing APIs. Really the only way that you can sort of keep up with it, right, is bringing in automation into the equation, having a structured way where you can automate that API security testing into your sort of developer pipelines as you do with your standard SaaS, DaaS tooling today. Is anyone here, okay, so one last question. Before this one though, is anyone here familiar with OpenAPI or Swagger? Have you heard of it? Do you know what it is? Got a few hands, nice. So this question here is, does your organization require the use of OpenAPI or Swagger contracts when building APIs? So OpenAPI is basically the de facto standard for defining and designing APIs. It's used very widely across many organizations, and basically it allows a human and machine-readable way to understand how an API operates, understand all the data in your requests, all the data in the responses, and all the authentication, right? If you think of what are APIs doing, they're really just sharing data across. They're sharing, it could be PII sensitive data, it could be tokens that you're giving to the API in order to get that authorization. So it's all data that's flowing in request and response. And it's really, centered around OpenAPI. It's a really easy standard because it's built specifically for REST APIs. And we see, mostly here knows, which totally understandable. Again, OpenAPI is, that's the end of the questions. OpenAPI is basically, more than just documentation, right? It's a way you can generate code server stubs from documentation. You can do security testing as well. You can also do developer experience, integration. So OpenAPI is a lot more than just documentation if you leverage it appropriately. And so here what you're kind of seeing is, in a typical software development lifecycle, right? You'll have your design, your testing, your coding, and then a lot of that times that happens locally, right? And developers are coding and testing. And then you might have, your automation in your developer pipelines, right? Where you kick off some QA, integration, functional testing as well. By the ability to introduce security in through the design phase is really how you can start to automate this process and build a structured process around this. So there's this idea of a contract. Really, it's the OpenAPI specification of the Swagger. It's a definition of that API, and you can basically leverage that contract as the sort of secure definition of your API. So you can run static analysis on that definition to ensure your API doesn't have any sort of data or security flaws just by looking at the definition. And then you can do a dynamic analysis on your API implementation without needing the source code, right? Just do that dynamic analysis using that contract as the guiding piece. So it's very targeted testing with the context of that API in mind. And then you can automate the whole thing through your whole pipeline, and then also give developers the tools where they can do that static and dynamic testing directly in their environments. So in their IDEs, right, the VS Code, IntelliJ's, Eclipse, and then also give security teams, right, the tools and plugins that they can leverage, so they can enforce all of those standards and any policies they set around their APIs automatically through that pipeline. So it's really centrally managed through the entire software development lifecycle. You're touching that API, through design, coding, test, and deployment all the way through. So we're going to give you a quick demo here of how this kind of works, more so from a developer's perspective. And we're going to use this photo sharing API. So we saw examples, right, of how you can buy currency with a wallet that you don't own or currency you don't own, right? Or you can edit an order that you didn't create or you didn't order. Those are all types of authorization issues on the object level where you're accessing an object or resource that your user does not have access to. You may have authenticated right into the API, but you don't have access to that resource. And so we're gonna go through a similar example with this photo sharing API. And basically we'll start with the design. So we're going to lock down that design. We're going to do a static analysis, and that's basically going to ensure the attack surface is reduced. So we're going to clearly define what data does this API expect in the request, what does it expect in the response, using the OpenAPI spec as the guidance. So we'll do a static analysis during that design phase here, which I'll show you the tooling that allows you to do that. Then we'll quickly test, so do dynamic testing on the API locally, ensuring are there any vulnerabilities when you test it against that contract. And then finally fix the issue. So we're going to look at, again, another authorization issue, which we'll fix in the API. And then when we deploy that code, we're just going to push it up to source control. That's going to kick off all the automation. And then again, those static and dynamic checks that we're doing locally, testing for and validating, are also going to do one final check in your pipelines to ensure if you miss something locally, you're going to catch it in your pipelines. So I'm coming over here to my workstation, and we'll start off with step one here, design. So locking down that API's definition. What does that actually look like? Here I've opened up my developer environment. It's a VS Code. And I mentioned, so from 42Crunch, we have a plugin that allows you to do all of this sort of static and dynamic analysis. And so for your favorite IDE, in this case VS Code, you can simply search here for 42Crunch. And you'll go ahead and find the Swagger editor. You can pull this down. It's totally free to use, and you guys can start doing this analysis today on your APIs. All you need here is the Swagger definition, which I have open on the screen. And then you need an active running API. I'm just going to actually run this API on localhost. So basically, I'll just come into my terminal, and I'll run this script here that basically just does a Docker compose, and it spins up my API. So it's got two containers going. It's got the API itself, and it's got a Mongo database. And this API, basically, it's a Express app written in Node.js. This is the code base here. If you guys want to play around with it later, you can see there's a ton of vulnerabilities, all related to like authorization, data stuff. So a ton of stuff you can learn from there. So here we see it started up. It's looking good. So here, we'll start with the contract. So we analyze the design first, right? So using this audit button here in the top right, since I have downloaded that plugin, you can see it says security audit. This does that static analysis of the entire file. It's going to really look for security and data flaws and recommend best practices on how to remediate those in the Swagger itself. So yes, we are analyzing documentation, and we're providing remediation on that documentation. But again, it's not just documentation. This is going to be leveraged for the security testing. Right? So we're going to actually do very targeted testing on the API automatically by having an accurate, well-defined spec, which this report here will ensure we do. So we can already see, we're scoring pretty high. 92 out of 100, that's very good. So this is actually a great definition. We just have a few minor issues. If we look at this little note here, security quality gates failed. This is basically the control for security teams. So you can tell the developers by setting policies like this to say, hey, I have a forbidden issue that we found in the Swagger. We found a string which is in the request somewhere, and that string is missing a pattern. So I can actually click on that issue here. It filters on it. I can go straight to the line number. Let me go ahead and close that. And we can actually see this is a delete picture operation. And there is a path parameter. It's a string. And that string just defines it as a string. There's nothing else to go along with that. Typically what you might see here is a minimum length set for that string, a maximum length, a pattern. So I can actually just click the audit here on the operation itself. So this is going to actually filter down those results to just show me what if all are any issues in just this delete picture operation. And again here, so now we can actually see a clearer picture where we have a missing pattern and we have a missing maximum length for that property. So really what you can do here is read more about these issues if you're unfamiliar, right? And you can quickly understand, okay, so why is it important for me to define what a pattern is for, in this case, what looks like a UUID. So a unique identifier that gets passed in the path here for the ID, right? So why is it important to have a pattern? Well, if you lock down that definition to a strict pattern of, let's say, what a UUID looks like, and then your API actually respects that definition, then you'll have a secure API. You're basically minimizing the surface area where an attacker can say, hey, I want to inject a bad SQL command or command injection, right? If you have a pattern that's being validated, they can't do that. So really that's the idea here, and you can see those kind of exploit scenarios, right, where you're susceptible to SQL injection if you're not thoroughly defining these sorts of things. And the fix is pretty simple. It's just adding in, what's the max length, what's the pattern, and really the tool helps you do that. So I can actually just hover over that schema with that string, and I can do here what's called a quick fix. And I can inject the pattern max length Super simple, super easy. You can even take it a step further. So we have, there's a feature here called data dictionary. So I just clicked on this little guy right here. And that's going to open up a new window. And I can actually see, do I have these data formats already in the 42Crunch system, right? And I scroll down, I see I do have a UUID here at the bottom. It's fully defined with an example, with a pattern, min, max length. So really all the guesswork is done for me. All you really got to do, I can even delete the pattern and max length because I don't even need those. And really what's going to happen here is I can use the format keyword. This is a Swagger keyword. And I'm basically saying this is a UUID. This is something you already probably have in your Swagger definitions. 42Crunch just checks this. I can rerun the audit, and now it's going to say, hey, I found that format, but there's no data dictionary in the actual document. Would you like to update the document? So when I click update here, it's actually going to inject all the data dictionary information, the minimum length, the maximum length, the pattern, automatically for me. And you can do that on the entire file in one shot. So basically, by using that data dictionary feature, I've added in that pattern, min length, max length. You can see now my score is much better, 94 out of 100, and I'm passing those gates. So that policy that's set, typically security would set this. They say, hey, this file should score minimum of 70. It shouldn't have any of these blocking issues. Shouldn't use API keys or basic auth. You can set those kind of things, and then have that feedback directly here. So right away, I know from static analysis, this file is meeting those standards. So I'll just save the file. Now we can actually dynamically test the API. So go back to the slide here. We've done the design part. So we've locked down the design using that static analysis of the Swagger. So this first one here. Now we're going to move on to test. So we're going to actually use that Swagger to do very targeted testing on the API. Because we've done the work and we've thoroughly defined it, now all the testing is automated. So really what you do is you click on the little scan lens here under any operation. What this does is it opens up the scan interface, and this is going to show me all the different operations of this API. I can click through them and test each one individually. And you can even create custom scenarios for them. So in our case, we're talking about an API that deletes pictures, and you can upload pictures, right? So if I want to delete a picture, I first need to make sure that picture exists. So you can even create these cool little scenarios where I say, hey, anytime I delete a picture, I want to first upload it. And you can even you can try the scenario. So I believe my app is running here. It is. So I can just click try it. And you can see in the sample request, it's hitting localhost. And it actually hits a post, which uploads this picture. And in the response, right, we get back that unique identifier of the picture. And then we can pass that unique identifier. We just save it in a variable here. And we pass it into the path parameter here. And the delete is successful. So we can successfully do what's called a happy path request, where we send in expected data to the API, and we get back a 200. This is one of the things a scan does. First, just to validate, because we're not looking at the code, right? We just have the spec and the API endpoint. We want to make sure that whatever's been deployed or implemented is matching the spec first. So this validates that. Then I can click scan. So I clicked in the top right there was a little scan button up here. And then that scan's going to run. Usually, it takes a few seconds. And then it's going to really write those or launch those test cases at the API. So it's sending real requests based on the OpenAPI spec. And you can see here from the results, there's 3 critical. So really the most critical one here, you see there's a broken authorization check here, again, at the object level for the delete picture. And what this is essentially saying is this user was able to delete a picture, this dynamic user with their token, even though they didn't own that picture. And they got back a 200, which was successful. And you can actually click on the JSON pointer here, and this will take you back to the OpenAPI spec to that respective function. So you can make any changes there if necessary. In this case, right, it looks like we're going to need a code change because the code itself isn't validating that a user owns that picture before it deletes it, right? So I can actually just quickly open up here and flipping back to the slide here, right? We just did the test. So now we've tested the behavior. We found a broken object level authorization issue, which we saw returns at 200. Now we want to implement the fix, right? So what I'll do here is I'll just open up the code. This is a Node.js app, so it's got a server.js. And then in here, we have that API delete function, right? So this is that delete picture. This is how it's implemented. And you can see we actually have a cool little comment in there that's helping us out that says there is indeed this BOLA, broken object level authorization issue, where really what's happening is a picture just gets deleted, right? You get the request, you get the picture ID, and it just deletes it. It doesn't really do any checks. So what we want to really add in here is, again, using the existing picture object, we can query that database, get back the actual picture. And we'll do that by doing this pictures.findOne. And we'll get back this result. I'll just call it picture. And so writing this function here, you could do some quick kind of boilerplate error handling here. Just if we get an error, throw a 500. But really what we want to do is that authorization check. So this right here that I've just added in. What we actually want to do, similar to the editing in order that we saw earlier, we want to check and see if the picture creator ID is equal to the requester's ID, that user. If and only if then, right? Then we will actually delete the picture. Otherwise, we shouldn't be deleting another user's picture. So I'll actually get rid of this guy right here. I'll just cut that out of there. And I'll put the delete picture right up in there. And then I'll just do a quick check, make sure the picture actually exists. Oop, picture. So make sure the picture exists and the creator ID is equal to the requester. In that case, we will delete the picture, right? And then otherwise, we'll go ahead and do the else. And in this case, what I typically want to do here is return a 401 and just say, this user is unauthorized. So either the picture didn't exist or that user wasn't authorized to delete the picture. So looking at this code, it looks pretty good. What do you guys think? I like the confidence. So what we'll do is we're going to build the app. It should take a few seconds, and we already have that scan interface open up. So once that app finishes building, deploying to Docker, we'll quickly run that try it test. So make sure, hey, can I get a happy path? Does the operation still work? Did we break anything? And then if so, we'll run that scan again, and it's going to do all those kind of dynamic tests. And then I'll kind of show you guys a couple of other ones, and maybe you'll kind of see the importance of why the documentation matters in this case. So it looks like it's good. We'll hit the try it. Again, it works. So we'll do a scan one more time. And so again, now we had that authorization check. We implemented the fix here. The last thing we want to do is deploy the code, push it up. I see we have a few minutes left. So now you can see, okay, there's only 2 critical high issues. That broken object level authorization is no longer here. So let's take a look at the summary, see what were all the tests that were executed. And you can see down here, there is the pass test. So we are successfully now getting a 401, and I put that forbidden message in there whenever we do that sort of authorization check. So you can no longer delete a picture that you don't own. And then you'll see in here, like we do the max length checks, the pattern checks. So really, all the data you have in your spec is leveraged here, and it's very targeted testing as a result. So you don't need the pattern, right? But if you have the pattern, you have more coverage in terms of testing. And so now the last thing we'll do here real quick is just push up the code changes. And you can see again, like what did I really change? Again, I just added in the UUID pattern min-max length to the OpenAPI spec, the Swagger, and then the appserver.js, I just put in that check here. So those are really all the changes. I'll just say, delete picture fixes. And so the cool thing now, when I kick this up, it kicks off that automation that I mentioned earlier, back here in GitHub Actions. So I can just refresh this, and I should have a new workflow coming up. And then I can take a look at that pipeline. So that's going to actually run the audit, and it's going to run the scan. So the static analysis, of your Swagger, and the dynamic analysis of the API implementation against that Swagger, all is running here in the pipeline. So this also discovers your API. So it's going to find any Swagger files you have in that source control, send it to the platform, the 4200 backend, basically to do all that processing. So basically, it can discover everything in the repos, run the static analysis, do dynamic analysis, produce all the reporting, and then you'll see, actually, which is pretty cool, and this right here, by the way, I didn't really show you guys, it's basically just a workflow in GitHub Actions. So there's a 42 Crunch sort of plugin you can get for GitHub Actions. It's really down here, and you're just using, so this is for the audit action. So you're really just referencing that plugin with a token from 42 Crunch here. And so just by adding that to your pipeline, you get that automation, right? And then you can also upload those results to code scanning. So if you guys are familiar with GitHub Advanced Security, you can basically surface security reporting in the GitHub portal here, so in the security tab. So those static and dynamic checks that we're running also get surfaced in this code scanning. You can filter on tools, so like my static checks, and I can see all the areas where we haven't defined patterns, et cetera. Same information that you would get sort of in the developer environment as well. And then you can even see like where was the very first SHA where this was introduced on the commit, as you can track the sort of life cycle of that issue. That's pretty much it. I think the pipeline's still running. Any questions while that goes?
Do you have or do you know of any GitHub actions that will identify infrastructure as code that creates APIs and doesn't define an OAS contract?
I mean, typically Typically, I've seen OAS defined with that. Now, if there's no OAS defined, we do have there's another tool here that is called Capture. It basically helps you use traffic, so real traffic, to define that spec. You can get it based off, HAR files, HTTP archive, PCAP files if you have network traffic. You can just take a Postman collection, dump it in, it gives you back a spec based on the Postman collection. So yeah, there's ways you can get this spec, but I'm not totally sure on that one. Yeah, so the plugin I'm showing you here, it's Azure DevOps, Jenkins, GitLab, really all the major CI/CDs, right? Your favorite one, and then everything's API driven too. So scripting, there's a ton of ways you can sort of integrate this. And it looks like it finished. You get cool little reports in here as well. So basically, where I ran that scan, you can see some reports that link back to this is the 42Crunch backend. And then again, all that stuff gets surfaced in the code scanning here as well. So we're QA, and I think we hit time, but any questions?
If you have questions, I can run this mic to you if you just raise your hand.
You guys can come up and talk to me too after.
On that delete item scan that ran,
Yeah.
the one that failed, that was the 𝗬𝗫𝗀𝗀 problem, was that a test you built or is that built in?
It was a test I built. Let me show you. Basically, it was this. Under authorization tests, I basically added this guy. So you basically define, hey, what's your authorization test? You can define this sort of like token swapping. And I can say, hey, I want to swap token A with token B and just tag it, say, hey, delete picture. So you basically just create this test over here. And you basically choose like what tokens do you want to swap. And you can apply that to any function. You can do it for BFLA. We didn't look at BFLA. It's like broken function level. So if you have an admin function where you must be an admin to access it, you can do the same kind of swapping. But yeah, you just define the test and then you can tag it. Most of the tests are automatically run from the spec. But for that authorization check, you would just have to tag the API with that.
We can take one more question, and then if you have questions, I think they will be up there for a little bit. And then you can always talk to experts in the hub. Anyone have a question?
Thank you.
All right. Thank you so much.
Thanks, everyone.